I'm going to talk a little bit about eGPUs today. I'm DJ Ware, and this is the Cyber Gizmo. So let's delve into this topic. Why would you even look at something like this? Why would you want an external graphics processor? Well, you might have a laptop, and that laptop may have a very low-powered graphics processor, and many of them do. So how do you fix that? Or what if you want an additional graphics processor to maybe absorb some of the load off of your current GPU? Maybe you're gaming and streaming at the same time. You could just put in two machines, but that's kind of expensive as well. Or you could add just a eGPU and then have one of them dedicated to performing the streaming task while the other one is performing the gaming task, for example. So today, though, multiple GPUs is kind of a problem. I mean, the days of being able to link them together and being able to use them as two processing cores, but yet they act as one, that's pretty much dead. Let's talk about what is an eGPU then. In simplest terms, it's plugging a powerful graphics card into an external box connected to your laptop. And I have one right here. This is, let me see if I got it up the right side up. There we go. This is a Pocket AI. This is made by obviously NVIDIA, but the board and the enclosure is actually constructed by ADL-Link. I bought this myself. This is not a sponsored review or anything. But as you can see, it is a blower style card. It's also very small. Fits in your pocket. That's why it's called that. But it is a blower style card. The fan is here and the exhaust is here. One of the things, though, if you look at this, you can see right away what it's missing, right? There's no video ports. There's no HDMI or DVI ports on this. So this is kind of like a data center graphics card. In fact, this is actually a RTX A500. This only draws about 25 watts max. If you look at the specs for the RTX 3050, I think that one can draw up to 60 watts. So they obviously had to make some compromises in this. So they had to reduce the number of shaders. They also had to declock it a bit. There are lots of GPUs that you can get. So let's look at a few of them. A good site to go to for, not only advice on what to buy, but also advice on how to set it up is eGPU.io. And I'll put a link below for you to go find that if you're interested. They have a number of enclosures on there for graphics processing units. So the idea is you would take an old graphics card with an old PCIe style graphics card and put it in the enclosure. Now, the most common enclosures are Thunderbolt because they've been around longer. There are some coming, though, that use NVMe or NVFF. NVFF is your slot for your Wi-Fi card. It's the small one. There are ways to connect boards up to that you can wire. If you can get out, you can go out and connect Oculink, which is what it's called when it leaves the box. And then that will connect to an enclosure or a board that has a PCIe slot on it. Now, currently, Oculink is limited to, I think it's either 4 or 8 lanes present. And, of course, there's going to be limitations with your CPU, too, since you may already have an internal GPU that may be occupying part of the PCIe lanes that your CPU has in support. But you can go up to 8. I think there's work that's currently being done to expand that to a full 16. Oculink is faster than Thunderbolt. It doesn't have some of the latency issues either. It's about 25 to 30% faster than Thunderbolt 3 or 4. Now, Thunderbolt 5 is just starting to emerge, so I'd have no figures on that, but I do know that doubles the speeds and feeds of the Thunderbolt bus. Currently, Thunderbolt is 40 gigabits per second, and this will take it to 80. So Yeah, it's still not your desktop kind of performance, but hey, if you're looking to take something on the road, you really want to pack your desktop to go traveling with, why use an eGPU on Linux? Well, first, if you're a gamer, you might want a smoother gameplay, higher resolutions, and more demanding titles. The other reason, if you're a gamer, you might want another GPU is to split your gameplay from your streaming. A lot of you gamers stream, so instead of going out and, as I had mentioned at the start of the video, instead of buying two PCs, you might want to have one GPU handling the game and the other one handling the performance of your stream. So what about content creators? Well, you can boost the performance for video editing. There's 3D acceleration in most of the video editors that will take up some of the more graphics intensive tasks. And that would be there would be some specific editing workflows with eGPU acceleration. So those have to do with effects and being able to decode X264, X265. Also, even ProRes from Apple is in that mix, and there's also enhancements that call in the graphics processor when you're adding special effects to the video footage. So, and finally, when you're rendering the video, that comes back into play again. You might also find that there's an acceleration that's done during color encoding as well. So what about, there's also professional uses for this, for an eGPU, that there are people that, of course, do 3D modeling for a living. There's also people that do high-end graphics artworks that requires an external that requires a GPU to accelerate that work. And there's also work that's done in medicine that requires the GPU. Mostly that's computational type stuff, CUDA type stuff, if you will. What do you need to choose the right eGPU setup then for Linux? And this is where I got wrapped around the axle. So, I'm always willing to talk about where I have problems with stuff. This was to be honest, this was the first time I tried to put an eGPU up on the new laptop that I have. And I wanted something that was cheap to play around with. I don't want to go out and buy a 4090 and then find that, hey, this isn't going to work. That's an awful lot of money to spend on something just to see if it'll work or not. So these run about $300, I think, something like that. They're not cheap either, but what do you need? It depends on first of all, what you're running. The amount of pain and suffering that you can go through, and I did some pain and suffering that you go through to try to unhook the existing open source drivers from Novo and then trying to replace those with an NVIDIA driver. I know most of you have done it. Most of you have had that experience. It has gotten easier, but there are still some distros that are kind of hanging back and making you do it the old-fashioned way, where you first have to figure out how to get the old driver unhooked. How do you get it out of there? Because it's going to be sitting, if you go to install the NVIDIA driver, the first thing it's going to tell you is, if you try to do this from a working distribution that's in a GUI, the first thing it's going to say is, hey, you've got a video card in use. So get rid of it. You got to turn it off. And then when you turn it off, it's going to stop and tell you, hey, you're running in graphics mode. You can't do that. You got to be in multi-user target or a single user target to install me. It's a real pain in the butt. Then because it's because NVIDIA, this is the proprietary driver now. So we haven't even got to the other ones yet. So there's so once you get through all that nonsense, then when you go to compile it, do you have all the prerequisites on your machine to be able to compile the module? Somebody asked me, why was I compiling the module for ZFS? Well, in DKMS, that's just the way it works. You get to recompile the module externally, and then it will then pack itself. It'll start and get ready to run. The next time you reboot your machine, that module, if it's successfully built, it'll come in and you're all set. Your driver is ready to go. However, However, I'm running a 675 kernel, and I had to end up on, I think it was 545 was the version number, which is marked on the NVIDIA site as in beta. So that's probably not going to be something you're going to want to do. And yes, I did run into trouble with it, but you don't need to understand all that. But so I'm running on EndeavourOS, and EndeavourOS is, I chose KDE, which makes it by default Xorg. So Xorg has some special problems. Now, I'm going to say this, and people are going to misconstrue it and say you said something else, but let me be really careful and pay attention to what I'm saying. On Xorg, you can only assign one graphics processor to a X window, period. One and only one. Yeah, there's workarounds that you can futz around with, but you may have varying degrees of success with that. Basically, if you look at the ways people on Xorg get around this problem is they go to the BIOS and they disable their graphics card that's internal, and then they can use the external one as the primary and they're all good to go. The second way is they have, there's eGPU switch. Yeah, eGPU switch, and there's also G switch. Those are two open source projects that allow you to switch your GPUs on the fly. I can get those to work, sort of, but you notice that there aren't any video slots on here. So what it was doing is it's flipping these over completely so that this now is taking up both responsibilities. It's not only rendering, it's also responsible for the display. Well, there's no display on here. So, yeah, I mean, I could see it running, but it was a black screen. It was nothing happening on the laptop screen. I'm sure you've seen that before too. But yeah, that's not very useful. That's not very useful at all. So I went through some of the workarounds. You can use nvidia-prime, and that now certain cards, this being one of them, does not actually support nvidia-prime. So you can't, it didn't even show up. There's when you do the LSPCI, you can look and see what comes back. I will refer you to the Arch Wiki on the eGPUs. One of the things, there's two things that the Arch Wiki does. It talks about some of the workarounds and some of the ways to do that. Unfortunately, most of the workarounds they have on there do not work on modern hardware. So I don't know. They probably work on some other hardware, but not on a Meteor-Lake machine. No, the problem that I ran into, to be honest, is trying to switch over to primary. The driver kept insisting, and this is an Xorg, kept insisting on switching to the Meteor-Lake CPU. So it's over there trying to send NVIDIA API calls to an Intel box, an Intel-built GPU, and the Intel-built GPU is going, I don't know what the hell you're trying to tell me to do. And so it was failing with all kinds of weird errors. And so that I couldn't understand. I couldn't get it to switch. There was no way. Even after running the switch and seeing the black screen, I would go log in on another laptop to get into it via SSH and would look at it to see what it was actually looking at. It was still running on the Intel GPU. So yeah, the switch did not work, I would say. After tearing out what remaining hair I still have, that's why I'm wearing a hat, because you see the bald spots. But after tearing out the hair I still have, I finally decided, you know what, there's got to be an easier way to do this. So, thank you, Arch Wiki, for this. You did provide a lovely link that showed me the actual NVIDIA drivers documentation that was written by NVIDIA. Wonderful guide. Chapters, I'll give you a link to that as well. There's chapters 32, 33, and 34. If you're hooking up an eGPU and you're using NVIDIA, go read that. That was beautiful. It had clear things in there, and it was documented. And it was clear that I was never going to get this to work on Xorg. So throw Xorg out, I installed this was early in the morning. I think it was about 3:30 in the morning. I installed the session for Wayland, and that puts in all the dependencies, and then I have to reboot the machine. And then it comes up, and I get the little thing at the bottom. Of course, it doesn't switch out of 4K mode, so now I've got type about this big on the screen. So I'm looking through a magnifying glass to see what the heck it is it's trying to tell me. And so I switch it over to Wayland, and it comes up, but then I don't have any menus, and so I have to regenerate the KDE menus. This was just one piece of fun after another. I mean, so finally got the menus back, and then everything was working. And right away, I noticed that this guy, the fan starts cranking up, and I'm like, oh, that's good. And I look over at the power draw, and it's up at 25 watts. And I'm like, oh, that's even better, because I know the thing is actually drawing. So it's starting to render, and I bring up NVTop. NVTop is a great tool. If you have multiple graphics cards, you can see exactly what both of them are doing. I'm seeing major activity on this thing, and I'm seeing some activity on the Intel. So I'm realizing that, hey, they're splitting the load like they're supposed to. Now, not equally, because remember, it's based on the window there as well. The compositor that Wayland uses in KDE, it's KWin that does all that work. So, yeah, I understand that if you're running on GNOME, this is a heck of a lot easier. But on KDE, yeah, KWin is there. It does work, and it works beautifully. I have to tell you, it does work beautifully. So I went and I ran my benchmarks. I went out to get Heaven, the Unigen Heaven, and I bring it up, and immediately it starts running on the Intel, and I'm like, oh, there was a lot of blue smoke coming out of my mouth, but you know, I did RTFM. I did read the manual, and in there it was pretty clear that you're going to have to pass a variable to each command. That way it will pick it up and send it to the appropriate card. So I'm not going to include that. It's in the Arch Wiki that's documented there. It's a pretty long string. There's a command called nvidia-prime that will do that for you, but be careful. It's based on ordering of the GPUs, so it asks you for 1 or 0. So make sure you're sending it to the right one. I found that didn't work, so you can actually pass it the PCIe bus ID, and that's what I did, and that was what finally worked. So it starts running there, and I can start looking at the benchmarks, and the benchmarks are terrible. As it turns out, the Intel machine is about 20 frames faster than this is. So, yeah, but it was working, and that's all I was trying to get done. I don't care if that was poor performance or not. I do have some older machines like these Nux behind me that this would be a great benefit for, so I may stick one of them back there. But the other side of things is that I wanted to record the screen as the benchmark was running, and so I bring up, I think it's called Spectacle. So, yeah, all these new things in KDE is great. So I get that working, and I notice that the load is over on the Intel. I'm like, yes, that's good. But apparently it was sharing, because it was adding load to the other side as well as the benchmark, which is not good. That's not what I wanted, but apparently that's just the way it works. It load balances between the active screens. The two things that are key to this for your benefit, if you're going to try to walk behind me and try to get one set up for yourself, is use the NVIDIA. Now I'm using Arch. I'm using EndeavourOS. However, this should work. The nvidia-inst, it's a package that has an installer in it that figures out what kind of card you have, what's the latest driver that's at NVIDIA's site, It'll download what you need, and it'll install all the dependencies for you, and it'll chuck the open source driver out the window. So you won't have this argument that happens between NVIDIA's proprietary driver and this one. So it will, by default, install NVIDIA DKMS, which is what you want. It'll compile it, and that'll all work great. But it also installed all the dependencies I needed in order to compile, like that had the kernel headers and all that stuff that you need in order to build a module. So that was great. That was perfect. The other problem I ran into was the UDEV it'll call the Thunderbolt driver, and the Thunderbolt driver has to authorize, it wants authorization for any new device that's attached to it. You only need to do this once, but it was flaky. Go figure. It would be flaky. And it would, sometimes the card would just disappear. And that's because the authorization timed out. It was waiting for an authorization. It was going, come on, I want the authorization, and it wouldn't do it. So what I did was I created a UDEV config, which automatically authorizes. If you want that, I can probably update my GitLab page and stick it up there for you so you can have it. But yeah, that cured the problem. But of course, you don't want to run that way all the time, because anybody that wants your machine, all they got to do is plug a Thunderbolt device in, and you automatically authorize it for them. So that's probably not the best thing in the world to do. So once you get those two things done, you've installed you got all the session support for Wayland up, you should be in good shape. There wasn't anything I had to do except whenever I'm running an application that is using OpenGL. And by the way, Vulkan support comes up, and I'll show you the proof of that. So yeah, it's all there. And that was good news. What are some of the challenges, I guess? So first is that in adding an eGPU, some of the drawbacks are cost. Obviously, you have a device you have to buy to stick a card in. You have to have a spare GPU, or you're going to have to go out and buy one. Some of the other problems you have is portability limitations. Like, what if you get too small like this, is it really useless? Is it useless, or is it really worthwhile using it? So from a standpoint of reversing this, so that's probably what I will do on the laptop, use this to support all the supporting tasks, and then use the onboard GPU to do the heavy lifting for now. So until I figure out what else I want to do with it. But the other one is thermal management. This gets up to about, it tops out at 91 degrees or 94 degrees. This was running pretty good, about 67, but man, I accidentally touched the sides of it without the silicon. Yeah, keep the silicon on. That'll protect you. But I didn't have it on. I was kind of concerned about airflow a little bit, because blower cards they're not the best coolers in the world. But yeah, it's hot. Yeah, it was hot. It put a red spot on me. So it was that warm. So what about some of the future of the eGPUs? So on Linux, I think it's full of potential. We're talking about some of the problems that I had, but remember, this is the first time I've done it. So a lot of this was trying to get ramped up to understanding what was going on here, and not finding a lot of documentation in the distro itself. But thank God for the Arch Wiki. I mean, that really helped a bunch. So you guys that are doing that, you're awesome. And thank you so much for the work that you guys put into that. So some of the positive trends, the kernel improvements. So recent Linux kernels have made significant improvements to the eGPU support. I use Thunderbolt on my storage arrays. It's that one right down there with the light on. That's a Thunderbolt enclosure. I use Thunderbolt for connecting my ZFS pools to my NUCs, because there aren't any PCIe ports in the NUC, so you have to figure out some other way to do it. There's been a lot of community development. I mean, there's been things like we talked about the eGPU script and the and the G switch. I mean, my comments on those are they seem to work fine, but the problem is that when I switch, it's expecting this to take over the display. So it wasn't the script's fault. It is that the device wasn't capable of being a GPU. I actually had to go modify the script because it was correctly saying you don't have a second card. So I had to kind of fool it into thinking that it was really there and it would work and it would run. So the rise of AMD GPUs and AMD GPUs tend to have better native Linux support compared to NVIDIA, go figure. So making them a modern choice for eGPU setups on Linux. Additionally, AMD is showing interest in developing open source drivers, which could further benefit all of us on Linux. So I hope that they do that. I do. I hope they do that. There's also growing demand with the increased popularity of laptops for gaming or content creation or professional applications. The demand for eGPU is likely to continue to grow. So this is going to lead us to more manufacturers offering eGPU enclosures and compatible hardware for the laptops that we're trying to do. It may also include ports that are on the outside of the laptop that are set up to handle Oculink, for example. What are kind of my final thoughts on all this? So the future of eGPUs and Linux, I think, looks promising. There's improvements that are coming along. There's a growing community. There are sites like the ArchWiki and eGPU.io that's a wealth of information. Oncoming driver limitations and being able to address security concerns, getting wider compatibility. I think all of those are key factors that will make this more widely adopted. So in final, what would be an alternative if you thought, well, geez, I don't want to use an eGPU. That's an extra cost. It has overhead. It's too slow. I really want the full use out of the card. Well, what you could do is what many people have done, and that is install the eGPU in your virtual machine, like Proxmox, for example, and then pass. So you'll need to have an internal GPU for the use of Proxmox, and then you'll need the external one that you can pass to VMs. Some of the key takeaways from today is eGPUs will unlock powerful graphics processing capabilities for your Linux machines. It'll help boost performance on demanding tasks. And some of the really cool things about Wayland in this space is the ability to have load sharing between multiple GPUs. I just think that's awesome. Compatibility, though, I think that's a work in progress, and it'll get better. It'll get better. It always does. Setups can vary from being 16 hours in and you go, oh my God, there's got to be a better way than this, and there is. Stay away from Xorg. I know a lot of people like Xorg, but Xorg has had its day. It's old. You can't. Yeah. My dad once told me a story. I have a story I want to share with you. So he bought I was very young, but I think it was when I was 1 or 2. Some of my earliest memories are around 2 or 3 years old. But one of the things I remember was he had bought this car. I think it was a 1950 Ford. And it was pretty much, it had been through the mill. It had a lot of miles on it. And this would have been a 7-year-old car, right? So, and he was driving it to work and bringing it back. And then my mom would use it on days where she needed to run errands and she would drive him to work. The car was having problems. It needed work. It needed a new clutch. It needed new seals. It needed, all the basic stuff, the shocks and the springs and all the kinds of things that wear out on a car. But there was some major things, like he had to replace the water pump and he had to replace the fuel pump, and it was just getting to be a long list of things to buy. And he finally realized that he kept good books, and actually my mom did, but they got looking at it and they were like, you know what, we could buy a new car for all the parts you're putting into this old one. And my dad, finally the light came on, he said, you're right, I'm buying an old car. and I'm paying the price for a new one. So what's the point? Yeah, he finally got it. And that is the point. At some point, your time is worth something. And if you're having to put in all these workarounds, maybe it's better not to bother with it and just go with the new thing to begin with. Now, there's still limitations on the Wayland side. I know. I ran into some of them. There's also the issue of being able to do fractional scaling, which doesn't exist yet. Hopefully that'll be coming soon. They're working on it. So I think, yeah, there's some challenges, but the performance gains are definitely worth it. With that, I'm gonna thank you to my patrons, and I thank all of you. Thank you so much for your support and making this video possible. It was you that helped me to be able to get this done. And thank you for the loss of sleep. No, I'm kidding. So it was worth it. It was well worth it. It's, when you put in a lot of work and you go, wow, this is never going to work, and all of a sudden it does. It's like that feeling of accomplishment that you get after being beat down by the system for a while. Yeah, it's nothing like it. And that's one of the reasons why I like Linux so much. It beats you down all the time. No, I don't like that part of it. Not a masochist. So anyway, hope to see you in the next video. Bye for now.